This video is on Newton's third law of motion. Question 1. State the name of Newton's third law of motion. State the equation for Newton's third law of motion. Newton's third law of motion is called the law of action and reaction. We need two objects and one force. So the equation is the force of object 1 on object 2 is equal to minus the force of object 2 on object 1. So these forces are equal in number, magnitude, and opposite in direction. So on the left side we have a plus sign, and on the right side we have a minus sign. So they're opposite in direction, but they're equal in magnitude. So force of object 1 on object 2 is going to be equal to magnitude of force of object 2 on object 1. And we know F equals ma. Question 2. Give 3 examples of Newton's third law of motion. 3 examples have been given to you. So, man pushes wall forward, wall pushes man back. Do you agree if you push a wall forward, the wall is going to push you backwards? Part B. Fish pushes water backwards, water pushes fish forwards. Do you agree that the fish's tail or fin is pushing the water back, and therefore the water pushes the fish forward? Part C. Earth pulls man down, man pulls earth up. Do you agree that when you jump up, the earth is pulling you down and you're pulling the earth up? Part D. Fist hits head backwards, head hits fist forward. Do you agree that if you punched someone in the head, your fist is going to slow down while his head is going to speed up? Part E. Rocket pushes gases down, gases push rocket up. Do you agree that when a rocket goes up, the gases go down and the rocket goes up? Part F. Baseball hits ball forward, baseball bat hits ball forward, ball hits baseball bat backwards. Do you agree in baseball, if you hit a ball, the bat slows down? That's why the baseball bat is going backwards. It actually continues to go forward, but it slows down. So in that way you could say it's moving backwards. Part G. In space, a man throws a rock forward, rock throws a man backward. Do you agree if there is no air resistance, if you threw a ball forward, then you would go backward? If there's no air resistance and surface friction? So you could see that we're going to switch the objects and switch the direction. Question 2. An 80-kilogram man on Earth jumps vertically upwards. The acceleration due to gravity near the surface of the Earth is about 9.81 meters over second squared. The mass of the Earth is about 5.97 times 10 to the 24 kilograms. Use Newton's third law of motion to determine the acceleration of the Earth after the man jumps. So when you jump, the Earth pulls you down and you pull the Earth up. So let's use Newton's third law of motion, which is this. We know F equals ma. Let's solve for the acceleration of the Earth. The acceleration of the Earth is about 1.31 times 10 to the minus 22 meters per second up. Okay. This is why we don't see the Earth move up when we jump, because the acceleration is so small. Question 4. A machine punches a stationary piece of paper to the right, which has a mass of 5 grams, which brings the speed of the paper to 30 meters per second in a time of 0.04 seconds. Part A, what is the acceleration of the paper? We're going to use A equals dv over dt. Part B, what is the force in which the machine punches the paper? F equals ma. And remember, force has a number and a direction, so it's to the right, the paper. Part C, what is reaction force in which the paper punches the machine? So the paper punches the machine with a force of 3.75 newtons to the left. The paper slows the machine down to the left.